linear exponential out of different situations. So a linear is where the quantity grows by the same absolute amount. So like the rate of change is the same, or we call it a slope in a linear growth. An exponential, it grows by the same relative amount, meaning look for the word percentage. If it grows by a certain percent, then that means it's not exactly the same amount, but it's the same percent every time. And so that grows exponentially. So first, linear growth is y equals mx plus b. That's a linear equation. And you guys remember m is the slope and b is my starting point. So we're going to find the slope and the y-intercept, or the initial value, b is called, and put it into an equation. So an exponential growth is when it grows by the same relative amount, by the same percentage. So remember, again, watch for that word percentage. And that is an exponential equation, where this is the equation that we looked at in chapter 9, where 1 represents what we're starting with. So this value y gives me, after a certain amount of time, how much do I have, including what I started with. And then the r is my rate, and the a is the initial value, and the x is the time. Remember, the time has to correspond to the rate. So this is a funny graph that they show you in your notes called straight town and power town. So straight town, it grows along, but it just keeps going at the same constant rate, always the same. They go along together for a while, but then notice after a while the exponential just keeps growing more and more because it grows on what it's already grown. And so this is a doubling, this is a second doubling. We're just going to worry about first doublings. So in each of these next situations, you're going to have to identify if it's linear or exponential, and then answer the question by using the equations that we just wrote down. The number of students at Wilson High has increased by 50 in each of the past 4 years. The student population was 750 a year ago. What is it today? So notice I underlined as I was reading it, underline the things that you know are going to be part of the equation. Increased by 50, what do you think that is as part of the equation? And past 4 years, what is that as part of the equation? And then 750 years ago. So it is linear because it's growing by the same amount. And the initial value is 750. The constant change is 50. So m is 50, and the constant change is 750. So where does the 4 go? So we have y equals mx plus b. So y equals 50x plus 750. And then we can put in x equals 4. How much has it increased in the past 4 years? So that's where the 4 goes. So we put 50 in for 4 because for every year it increased by 50. So there's 4 50s, but we started with 750. So there's a total of 950 people. The price of milk has been rising by 3% per year. The price of a gallon was $2 5 years ago. What is it now? So it's increasing by 3%. So remember, that right there tells me it's exponential. And the 3% per year tells me that my t, or my time, needs to be in years. But what does the $2 represent? Well, the initial value is 2. The rate of change is 3. Remember, it's 3%, so we write it as 0.03. So here's my equation. Y equals a, which I'm going to put into an r, put 0.03, and then x is my variable that I can find for different years. Okay, so what was if the price of a gallon was $2 5 years ago, what is it now? So if it was $2 5 years ago, so that's why we put 5 in here, because they want to know what it is now, which was 5 years. So now it's $2.32. Tax laws allow you to depreciate. This one uses, so that's going to be part of our equation. The value of your equipment by 200 per year. You purchased the equipment 3 years ago for $1,000. What is it depreciated value today? So is this linear or exponential? Well, it's decreasing by the same amount every year, so it's linear. And my initial value is 1,000. My constant rate, this time because it said depreciated, I'm going to go negative 200. So my M is negative 200 and my starting value is 1,000. So this equation represents every year it goes down $200 from the 1,000 that it started with initially. So if I wanted to know what it was 3 years ago, then I put 3 in here, or what it will be, what is the depreciated value, because I bought it 3 years ago. So now it's worth 400 because it depreciated 3 times at $200. Okay, the memory capacity of a state-of-the-art computer storage device is doubling approximately every 2 years. If a company's top-of-the-line drive holds 2.5 terabytes today, what will it hold in 6 years? This is important here too. It doubles every 2 years. First, is it linear or exponential? Because it's doubling, which is a percent, it's an exponential. So my initial value is 2.5. My rate of change is 100% because it doubled. So I had 100%, now I have 200%, or my R is 1. So then my equation looks like this. But now because they said it doubles every 2 years, in 6 years, how many times is it going to double? 3 times. So you got to be careful on ones like this. They're trying to slip that in. But you don't put 6 in here, you put 3. Because it doubled 3 times in those 6 years. And then you put that in your calculator, and it's 20 terabytes now. The price of a high-definition TV has been falling by 25% per year. The price is $1,000 today. What can you expect it to be in 2 years? Is this linear or exponential? Because it's a percent, it's exponential. My initial value is 100. Oops, my initial value is 1,000. My rate of change is negative 25 because it's falling by 25%. So A is 1,000 and R is negative 0.25. And then I pull the equation out. Remember, you will be given these equations on the test. But after you practice this a bit, you're going to remember what they are. So I'm going to put in 1 minus 0.25 because it's falling, and 25% is 0.25. And then X is 2 because they want to know expect in 2 years. So it was worth 1,000. Now it's worth $562.50.